Arithmetic sequences. So here we've got a couple of examples. Just going to do a quick review on how we handle these things and to be able to write an equation. All right, so the first one that I have, I've got 23, then 19, then 15, then 11. Remember that arithmetic means that you are adding or subtracting the same number repeatedly. So I'm looking for that type of a pattern. So with the 23 and the 19, I think that that is going to give me subtracting 4. So if this truly is arithmetic, then that means subtracting 4 has to work repeatedly, which it does. So I know that my common difference here is going to be that negative 4. So I'm going to refer to that negative 4 as my m, also known as my slope if I was talking about a continuous function. The next thing that I need to be able to do is find my zeroth term. So if I were to go backwards, so let's take a look at the sequence up here. And just kind of copy down what I started with. What I'd be looking for is the term in front of the 23. So I would still use my same common difference here. So that means that some number minus 4 is going to have to give me 23, the first number in my sequence. Well, the number that does that is 27. So 27 is going to be my zeroth term, which means my b, also known as my y-intercept, if I'm talking about a continuous function, is going to be 27. All right, I think I'm ready. So I take out my equation, which is t of n is equal to mn plus b. Looks just like the y equals mx plus b that we've done previously. However, the t of n notation tells me that this is going to be a sequence and therefore it's going to be discrete. So I plug in my m, which is the negative 4 that I calculated already. N, I need in there. And then my b, is going to be positive 27. So there is my equation now. So if somebody were to ask me, how would I find the 19th term? So to find the 19th term, what I would do is I would plug in n is equal to 19 into my equation. And then I would go through and algebraically solve that. So I plug in the 19 where the n's are located. And remember that the left-hand side is just notation, so you don't do anything with that side. It's just saying that you're finding the 19th term. And if I go through and do negative 4 times 19 plus 27, that's going to give me negative 49. That'll be the 19th term in my sequence here. All right, let's take a look at the second one. Same idea. Take a look at what the common difference is going to be, so what number is being added or subtracted. And in this case, it looks like the number that's being added is 12. So my common difference is going to be 12, which is also identified as my slope. So I would say that m is 12. Then the next thing that I need to do is to be able to determine what the zeroth term is. So if I were to go backwards, what would be in front of the negative 11? So let's just bring down our sequence. Forgot the 1 on the 13. All right, so if we were to go backwards, the idea is still the same. So what number did you have to add 12 to get 11? All right, so that is going to give us our zeroth term, also known as our b. So in this case, I believe that number is going to be negative 23. Now that we have our b, which is negative 23, we can plug everything into our equation that we need. So I would say t of n is equal to, still the same formula, mn plus b, and plug in what I know. So t of n is equal to the m that I calculated, which is 12n, and then the b is going to be minus 23. In addition to being able to locate a specific term in the sequence, I can determine if there is actually a number in my sequence. So the question is or would be 485 in the sequence. Well, if it's in the sequence, then it's going to be a t of n. So what I'm going to do is I'm going to take my t of n equation and I'm going to put the 485 in its place. So instead of solving for t of something this time, I'm actually solving for n. So if I go through and solve that, if I do 485 plus 23 to get it to the other side, that's going to give me 508 is equal to 12n. And then the last thing I'm going to need to do is divide by my 12, which is going to give me 42.3 repeating. Now remember that n represents a location in the sequence. No such thing as being at a decimal location. So I would say, since n is a decimal, I know for sure that my number 485 is not in the sequence. And there's a little bit of review for arithmetic sequences.